So this week we are talking about multimodal and multitask models. These are machine learning models that can generalize. Multimodal models can generalize to understand different types of input. For example, the same model can understand images and text. And multitask models can generalize their knowledge across different types of problems, applying what they've learned from one task to solve another task.
So you can derive some sort of map of meanings in the embedding space. And it seems like we have gone one step further in that we can take data from whatever media, whether it's images, audio, or text, and be able to map it into the meaning space now so that they're all the same meaning space.
Hey, this is Sri. I'm a YC alum and a research engineer focused on natural language processing for search.
This is Will. I'm a YC alumni also and an independent researcher who's worked across e-commerce, cryptocurrencies, and financial industries.
Welcome to the Technium, where we talk about the edge of technology and what we can build with it. An optimistic look at the road ahead. How's it going? Well,
It's going well. No, I think we always chuckle because sometimes it's been a little bit since I've seen you, so it's good to be back. It's good to be back. How have you been?
pretty good. I am in a new place. There's like a different background every time in this season. And
Right. Yeah, I can see that you got a new setup, and I think slowly we're trying to up our production values little by little, and I think we're doing a little bit better. Yeah, I gotta up my setup game just like you. So what are you drinking today?
So I think this is a throwback to the first episode of the season, Vibes. It's some type of mysterious elixir. It will enhance my mind and body.
Wait, so the label is like black and white. It just seems like somebody made it in their garage. Move it over a little bit so that, because it's cut off in the vertical. Yeah, Vibes. Plus, it's Vibes with a Y. And so you you know the type of person that would name that. It's probably the Web 2.0 executive that made it big. And so they're like,
Yep.
Well, we'll take that naming scheme with us. I made my money, so this is just for fun, man.
Definitely. I'll let you know how it is.
Right. And so this time I picked up something from an Asian grocery store, something called Yuzu. It's a sparkling water, unsweetened, I guess citrus flavored, yuzu flavored sparkling water. We'll see how it is. It's got some sediment in there, and so hopefully this is good.
All right.
So what are we talking about this week? You said you were super excited about it.
Yeah. So this week we are talking about multimodal and multitask models. These are machine learning models that can generalize. Multimodal models can generalize to understand different types of input. For example, the same model can understand images and text. And multitask models can generalize their knowledge across different types of problems, applying what they've learned from one task to solve another task. And quite frequently, the same model is both multimodal and multitask. These two are increasingly correlated, and they can do some really cool stuff.
So to recap a little bit, what's the difference between multimodal and multitask?
Yeah, so basically a multimodal model can understand different types of input. So
Got
the
it.
same
Right.
model can take images and text and video and things like that
Mm-hmm.
as inputs and potentially outputs.
Mhm.
And a multitask model is a model that can perform well across different types of tasks. For example, it can detect objects and images, but it can also perhaps generate text to answer questions. It can do
Mhm.
multiple different types of things. And so why this is interesting is that in the very, very beginning of machine learning, and even up until recently, people have been working on machine learning models that can do one thing really well. So you would have one type of architecture that can do object detection. You can have another type of model that can do question answering. But increasingly, the way that the research is going is to combine these things into a single model that can take different types of input and potentially do multiple different types of things.
Wow, that's interesting in the sense that my knowledge of the latest machine learning is a couple years old, and I did not think that we would be here where we are able to train generalized models to do tasks across different domains and different media types. And so multimodal is the input to the AI system, and multitask is the output of the system. And what we're going to talk about today apparently is like how far we've gotten and what does this mean for a near and far future, I guess, where we speculate on how this will change our world.
Yeah. And I think, yeah, the key point here is also the generalization. So, we can talk about what could potentially be going on with these models. What does it mean that they're able to perform so many different types of things at the same time? Is this, evidence that they're learning something deeper about the world rather than just being sort of curve fitting or extrapolating from their inputs that they've seen and things like that.
Yeah, so if this is the type of thing that is right up your alley, hit our subscribe button down below and we'll get right to it. So then where should we start, Sri? Because like there could be a lot of different places we can start and go with this topic, because essentially what you're telling me is that we're that much closer to generalized AI, and it's no longer just in the realm of science fiction. It's actually within reach of the possible future that we have generalized AI. Am I incorrect here, or?
I think those are controversial statements, and I think
okay, we can pull it back a little. Let's start first with the multimodal and multitask. So I guess first with the multimodal, like you said before, like when it comes to machine learning and even the deep learning stuff in the beginning that made a lot of waves and splashes, those were AI systems that were trained specifically to do one thing. They were the Olympic athletes of their particular domain. But now it's like we are able to train people that are like regular factory workers that have common sense, which was way more difficult for AI than it was to train Olympic athletes, right? And so that's the basic breakthrough that you're talking about today. Is that right?
Yeah, basically. And so just to call out that a lot of this has been possible recently because of the transformer architecture that we talked about in our previous episodes, which we'll link to. So definitely check that out to get an understanding of why this unlocks all of this different potential. But yeah, so I think the best place to start is to look at a few of the press releases and blog posts of some very hyped up and popular models that have come out of some of these huge research labs, and just like discuss what they can do. So yeah, I think there are a couple of interesting models that have come out recently from Google as well as a couple from Deepmind. And the one that I want to start with is a multitask and multimodal model called Gato. It's a model that has 1.2 billion parameters, which is fairly small, actually, as far as transformer models go these days.
Yeah, I was going to ask, is it typical? Like, is it like 5'5" or is it like 6'2"? Like, what's the size?
Yeah, I mean, if you look at GPT-3, it has like billions and billions, like I think an order of magnitude more
I see
parameters. And so this is like fairly small. So yeah, GPT-3 has 175 billion parameters. That's
okay. Yeah,
actually
it's like
two
orders of magnitude smaller. I see.
Yeah. Yeah, so Gato is a modestly sized model. And what's interesting about it is that Deepmind has trained this single model to perform 604 different tasks, they say, across a few different domains, across natural language processing, not reinforcement learning, but like playing Atari games and things like that.
Yeah.
As well as like robot arm manipulation in like a 3D simulated environment. So it is a single model that can do different things that are seemingly unrelated, right? So like natural language processing would include like answering questions and things like that, or completing text. And then, you imagine playing a video game does not involve language capabilities at all. It involves maybe vision, maybe some understanding of state and things like that. And so this one model can do all of these things, not necessarily well at the state of the art of like specialized models, the Olympic athletes, like you were saying, of each of these sports. But it's sort of an all-purpose athlete that can do like lots of different things like moderately well.
Right. We're training the jack of all trades, and we're training them to be like number 2. There's no reason to be number 1. The cheer is that we're number 2, right? So
yeah, exactly. And
but you can be number 2 across a lot of different tasks. That's what we're shooting for.
Yeah, and I'm not even sure if Gato is number 2, but I would say it's like probably even imagine being in the top 10% of each of 604 different sports. That person is like very interesting, regardless of the fact that they're not like winning any medals anywhere.
Serviceable, right? Like they're in the amateur softball league after work or something like that. But in 640 different sports.
Yeah, exactly. So that's Gato, and the reason why it's potentially interesting is that that's a lot of different tasks, and the idea would be that in a multitask architecture, the hope is that different tasks can somehow help the model do better at other tasks. So for example, let's say that it learns some concept from manipulating robot arms. It understands some like spatial concept, let's say, and that could help it do better at video games or something. Or maybe even learning something about language. If it's seen a description of something, it will be able to apply that description to images that it sees.
Yeah, this is the main core thing that's so surprising about this. Like, it's not just that the input is multimodal, but that you wouldn't think that a whole bunch of text would have an embedding in some like high dimensional space that would have anything to do with spatial reasoning of a video game or something like that.
Mm-hmm.
Like it just seems so disparate that it's kind of crazy that people decided to try it. And I think this is an old idea, right? Like these multitask and multimodals ideas have been around since the late 90s, I think. Is that right?
Yeah,
well, nobody's like
sure.
really leveraged it until much
Yeah.
later, but at least in my research, like the ideas have been around for a while. It's just hadn't been practical until recently.
Mm-hmm. Yeah, exactly. Yeah, I think that this is the end game of AI research, right? Like, even if they were not able to manifest it, as you say, early on, I think the idea of AI would be to have something that understands the nature of concepts beyond just seeing the examples and then, imitating those training examples in a slightly different inputs, right? So the hope is that it actually learns, like it knows something, so to speak.
Yeah, that's so weird because like the idea of meaning, and it's something that philosophers argue about all the time. Like what is meaning, or like how do you know that somebody knows something, that sort of thing? Well, I guess if you have a set of weights that can generate the input, right, then you know that that's there. And so I guess you can also explore that it's an embedding space. Is that the correct term? Where it's like the abstracted representation of a concept in high dimensional space. Like to us, it just looks like a bunch of numbers, like high dimensional vectors, but that's still what this thing is using, right?
Yeah, so that's what all of the inputs to this model are converted into some input vectors, and then also the model has some weights. It has these parameters, right, that it's running its inputs through to generate output, and also its parameters somewhere are transforming its input into maybe some meaning vector, so to speak. So the caveat here, I think that there is a lot more investigation needed into probing the nature of what's going on and trying to understand whether, let's say, a description of something in text is close by in space somewhere to that same image of that same concept. That's what's going on. But I think that there needs to be a lot more investigation into whether these multitask architectures are in fact relying on this concept. But intuitively, I think it makes sense.
So it seems like see it seems like there's something there. It's not just like it's an embedding space that's not just tangled up, because you can do like man plus king minus woman equals queen and stuff like that. So it seems like there's some spatial order to the embedding space, so you can derive some sort of map of meanings in the embedding space. And it seems like we have gone one step further in that we can take data from whatever media, whether it's images, audio, or text, and be able to map it into the meaning space now, so that they're all, I guess, the same meaning space. So, well, same in the sense that there is a meaning space. I don't know if that two different training runs would give you the same meaning space, right? Like it seems unlikely that you would get that, but maybe the spatial relationship, the high dimensional spatial relationship between the different concepts would be same, if not similar. So
so Gato's out of Deepmind,
and so Deepmind is the people that, what did they do? The Go, is that right?
Yeah, they did AlphaGo. They did AlphaFold for protein folding. And so they've been coming out with some pretty heavy hitters. Yeah, so that's Gato, which came out of Deepmind. And then there are a couple of other interesting ones that I wanted to talk about. Actually, most of this has come out of Google and Deepmind. So
yeah, it seems like I haven't heard of any like small shops that have done groundbreaking work. There's no like AI startups that are doing groundbreaking work. It's all the big guys.
Yeah, which is unfortunate, but it makes sense considering how much resources are required for this.
Yeah.
So one other example that I'll just touch upon briefly is Google's MUM, which is a multimodal model which can basically be a search assistant. So you can take, for example, in their blog post, it says that you might be able to take a picture of hiking boots and ask, can I use these to hike Mount Fuji? And then Mum would be able to reason that, looking at the picture of the boots, they are this type of brand, or it has these features. It can somehow know some facts about Mount Fuji and how tall it is, or what is required in order to hike it, and then be able to connect these pieces of information and then answer your question. Can you use those hiking boots to hike Mount Fuji? And so this is
able
kind of
to do that?
No, so that's sort of an aspirational goal. I think right now what they are doing is starting out with this architecture, and then they say that they're using Google search data in order to train it for all of these different types of tasks. And so it is very much focused on the kind of Google search-centric information retrieval, information reasoning type tasks. Specifically, they're saying these kind of complex questions where you might previously have required multiple Google searches or even asking humans on the internet about this. Right. You might be able to use this model and gather information from the internet, and this model could answer these kind of complex questions for you.
Yeah, I mean, it's the vision of the 90s. I don't know if you remember push technology, where the vision on the web was to have these agents that go out and fetch this information for you and put it together. And it was relying on the semantic web so that these agents could read it and then join this data together. And it turned out that it didn't turn out that way. And so instead we made these models that doesn't require the world to be marked up semantically, and it's still able to put stuff together. And like you said, the agents that reason and be able to put together the idea of these boots are grippy enough for the conditions at Fuji. You need to have information from disparate sources. It's not quite there yet. It's aspirational, but it seems like it's close enough that people are starting to think that there's a plan of attack for that kind of question.
Yeah, exactly. These things are coming out as press releases to show the potential of these things. We're going to take it at face value, but I think there's more work to be done. But previously, it would be laughable if some AI research lab said, hey, this could be possible with our architecture, right? People would be like, get out of here. This is absurd.
Right. What you smoking? Now, I want some of that too.
Yeah, exactly. Yeah, presumably now, these people who have, reputations to keep among their peers are publicizing that, hey, we could do this maybe. Maybe not now, but it's within reach, and so that's pretty cool.
Yeah, the equivalent is if physicists, it used to be that saying you're working on time travel, you'd get laughed out of the room, but today I'm not saying it actually is, but it would be the equivalent of saying today it's not laughable if you said I'm working on time travel.
Yeah, but it is something kind of out of science fiction.
Yeah. Anyways,
so that's Mum, which is coming out of the Google search space. And then there are a couple of other interesting models that have come out of Deepmind again. So the first, or the other of which, actually, it doesn't have a cool name. It's just called Multimodal Interactive Agent.
Somebody failed in the marketing department there.
Yeah, they were doing well with the Gato, and we're gonna get to the next one, Flamingo. But this one, they just they're, I don't know, it's
phoned it in there. Yeah.
We don't have any other good ideas. But this is a model which manipulates a type of agent in a 3D environment. It kind of looks like, Rosie the robot from Jetsons. And it's
wait. So back up here. The AI avatar. The AI has an avatar in virtual environment, and their avatar kind of looks like Rosie the robot. Is that right?
Yes. Yeah.
Okay. In the general sense, I think I looked at the video. They look like cylinders and stuff like that. So it's not actually Rosie the robot. And is that a Jetsons reference? Do people really know what Jetsons are?
I don't know.
Because it's been so long since they had a remake, because Flintstones had one. But so I don't know if our listeners would actually know what the Jetsons are.
That's true. And I'm also not of the generation that should really know what the
Jetsons are. Right. You're making references to things that are before your generation.
Yeah. Anyway, it's a robot. It's a robot that kind of wheels around in a 3D environment.
Of course, 3D virtual environment, right?
Yes. Of course, the machine learning model has no shape, but it controls a robot that looks like this. And the idea of this agent is that you're able to give it text commands such as tidy up the room, lead me to the bathroom, whatever, right? And it is able to do this and it hasn't been necessarily trained specifically on all of the things that you can ask it to do. It has learned from training data from looking at, I think, humans move around the environment and perform tasks in response to prompt, but then it's able to generalize because it's able to react to novel commands and do novel things. And so this is interesting because it is kind of embodied. So previously we were talking about tasks that are fairly abstract, like things that you would imagine a computer could do is like take in some input, process it, and do an output. Right.
This is more corporeal, which you would think is the most foreign thing for computers to figure out how to do.
Yeah, exactly. So this is cool because it's learning to do this in a simulated environment. And then there are another area of research. There's another area of research called sim to real, which is the idea that you can take machine learning models that have learned spatial concepts in 3D environments and then translate that into the real world, and making sure that the model is able to take what it's learned from the simulation and apply it into the physical concepts in the real world. And so it's possible that you're able to take multimodal interactive agent, I guess MIA is the name, MIA. So I'll just call it MIA. So you're able to take like MIA and maybe combine it in the future with some sim to real type research and actually be able to have a little robot that can do things around the house.
Wasn't it a problem where if you trained AI in a simulated world, it wouldn't actually translate to the real world because it might have been exploiting like some aspects of the physics engine that wasn't actually present in the real world? Have they overcome that problem yet or no? Like, because like sim to real sounds like you're able to just run the training and simulation and then have it translate over directly to the real world. So is that not a problem anymore?
It's not like as much as a problem as it used to be. So for certainly like limited tasks like being able to manipulate a Rubik's Cube, like solve a Rubik's Cube, sim to real is able to do that really well. What happened? I'm not sure. Like I'm not like deeply immersed in that thing. I think it's a combination of improvements to the architectures as well as the improvements to the simulation environments to be able to generate better training data. And then as well as the improvements to the model so that they're less susceptible to overfitting on the nature of the simulation and more able to adapt to other unknown types of data. So that's MIA, multimodal interactive agent. And then the last one from Deepmind that we will go into is Flamingo. So Flamingo, again, this one has a cool name, right?
Yeah. They hired another marketing agent. That was when they had
they only have two marketing people.
right.
So one of them had to have a lame name. Yeah, so then Flamingo is kind of cool because it is a conversational agent, like a conversational model where it knows how to do visual and text tasks like jointly, meaning that Flamingo is able to reason about pictures. Basically, you can give Flamingo a picture and then ask it questions about this picture, like, okay, what's in this picture? What's interesting about this picture? What is this thing made of in this picture as well? And it's able to answer those pretty accurately. And so it's basically able to reason and have a conversation with you by looking at something and understanding the inferences and implications of what it's looking at.
Do you know what, as an aside, I know we're not going to go deep into like how these things are put together, but as an aside, do you know what the difference in architecture for Flamingo so that it's able to do this like reasoning or inference?
Yeah, so the interesting thing about Flamingo is that it takes kind of off-the-shelf image transformers and off-the-shelf text transformers and keeps those fixed, and what it learns, what Flamingo adds beyond these sort of building blocks is the reasoning aspect of it. So I think that's the one notable thing about the Flamingo architecture that I know, whereas...
So is the reasoning part of the architecture, is that also transformers, or they came up with something more like traditional programming rather than AI?
No, it's all transformers. It's just like Flamingo, like, so transformers are basically Legos now, right? And so they started off, they bought like some Lego kit, right? The off-the-shelf Vision Lego kit and the like off-the-shelf text Lego kit, and then they added their own Legos to that.
I see. And their architecture for transformers happens to be able to do reasoning for the inputs that were given by the other transformer sets.
Yeah, exactly. Yeah. Whereas I think that in Gato, it's trained like they're not using off-the-shelf components. That one model learns
Right.
from scratch, like about text
Right.
and vision and things like that.
Right. And
Yeah.
so okay, so then that's Flamingo, where you can like reason through things. You can't just like you not only can ask like what is in the picture, but you can ask about like relationships to the picture, such as like what is the koala holding or something like that, right? And it would be able to
Yeah.
answer. Right.
Yeah,
It may not
exactly.
like you can't ask it like why is koala holding like a bourbon or
You,
anything like that, but it
yeah, I
might
mean, you
try.
might,
Oh, I
you
guess
can
you
try.
could. Right, you can try because then it might like make up a story about how maybe if the background setting is in a bar and the koala is holding a bourbon, like ask why is the koala holding a bourbon?
Right.
A viable answer is well, it's in a bar, right? But then like a question that both the AI and humans might have trouble answering is why is there a koala in the bar? So,
Yeah,
but
exactly.
that's the kind of inference that you're talking about, right? Where you can ask like,
Yes.
why is there holding a glass of bourbon? Well, it's in a bar. That seems like it makes sense. So,
Yeah, exactly. Yeah, so it makes these types of inferences, and one of the other examples that somebody had posted on Twitter was that they had a picture of like basically a toy city in which like a normal sized cat was sitting, right? So it was a very
yeah.
very large cat relative to all the buildings and cars and things.
Well, so this was
And
a generated photo, like whether it's photoshopped or generated, it doesn't matter. But
yeah,
basically, the image is of a big cat that towers over buildings, right?
yeah, basically.
Okay. Yeah.
And then they fed it to Flamingo and then
Uh huh.
asked like what is interesting about this picture, and it said, oh, like the cat is like really large, like this is a picture of a city and it has a huge cat in it, which is like
Wow. Okay.
interesting.
Yeah.
Yeah, because like you need to know like what a city is, roughly how big cities are relative to cats, and then like also like the question was what makes it interesting, right? It's sort of a
Yeah.
subjective
Right.
question.
That is so. I am surprised. Can we go back and say like what's so surprising about this stuff? Because like for a normal layperson, I think so. One of the things is I hear about this stuff and I'm just amazed. I'm just it's like wow. But
Mind
then like
blown.
when yeah, like not just mind blown, but like it's hard to describe the amount of surprise because
Mhm.
given what I know about technology, like this was supposed to be decades away. And so
Yep.
somehow it's here today and I'm like, how is this possible? What is the common thing that is making all this possible? Aside, apparently it's Transformers, but
Watch our other
the
episode about Transformers.
right. Watch our other episode about Transformers. And so some of the true, I guess you could say truisms of machine learning and deep learning before just don't seem like they're true anymore. And
Hmm.
so so let's go over some of these because like when I tell normal everyday people that are not in tech, they're just like that sounds like something maybe computers could do because I saw it in a movie once, right?
Yeah.
like hey, let's enhance this picture. It's like pixelated
Right.
and then it becomes enhanced. For the longest time, I laughed at that because that's not really possible in the traditional sense because you'd have to like make up information. But now
Yep.
actually, it's like the tech actually caught up with the art, so it's not infeasible anymore. You can actually depixelate pictures because computers can reason about these pictures and then just fill in more pixels by adding more pixels given what they understand about the world, right? Because they have
Yep.
this meaning map or like the embedding space, like the world of meaning to fill things in. So I guess so one of the things is like we talked about before that like multimodal, like a lot of the AI is multimodal, so it can accept a lot of different media today, right? And
Hmm.
so now it's not specialized on one task, and so it like generalization is a lot better. The other
Yep.
seems to be that you can train these models to do reasoning through this like concept space so that it can tie concepts together. So you can ask questions and it's able to do a chain of, I guess, like rudimentary reasoning about like
Hmm.
what they're seeing. And so you can ask things like, where does a shoe belong? Like, what what should Weather Bear wear for this weather or something like that? Like what should I wear for today's weather?
Is that
Um,
a children's character?
yeah. Sorry, Weather Bear is a
Okay.
children's character. And yeah, that's the exercise. Like given the weather today, like what should Weather Bear wear? And so
Hmm.
this is an exercise typically for children, and like AI is actually able to do that sort of thing now without
Yep.
us like explicitly programming like what is rain, what is the weather, and then tying those inferences together. Like it learned it
Yep.
from a set of data. And then
Hmm.
also what's surprising nowadays that is that used to take lots and lots of data to train these sort of things. Like, but you're telling me now also that like there's these one-shot learning models in which you don't need nearly the amount of data that you used to. Is that correct?
Yeah, that's right. And actually, that's the other aspect of Flamingo that is interesting, is that it's also a few-shot learner, meaning that it was trained on these tasks about answering questions from pictures and things like this, but it's actually able to take prompts from the end user and say, okay, here are some examples of what I want you to do, and then it will be able to generalize to new visual and text-based tasks. So yeah, that's another aspect is the few-shot learning.
Yeah, and so that's also surprising. So like all these things are surprising, or like some of these like what you would think of as common sense tasks. It requires a lot of different disparate things to pull together, and it's like not easy by any means. Like we usually, as like lay people, you would often think that it's something like chess that's much more difficult than putting dishes in the dishwasher or folding laundry, because like most people can do the latter. But as it turns out, for computers, that's so much harder, because fabric can fold whichever way, and whereas like chess is like a known deterministic game where you have perfect information, and so you don't even need this deep learning AI to write one that's fairly competitive, right? And so all of these things are fairly surprising. Did I miss a couple others, like these like new surprising things about all these like new learning models?
No, I think that's a really good recap of why this is all really, really interesting. And just to sort of draw, benchmarks or like lines of how quickly things have progressed. So when Andrew Ng started Google Brain back in, I think it was like 2010 or something, which was the first sort of major research lab focused on deep learning for these types of tasks, his motivating reasoning was that computers are not able to answer the question of, given a picture of a cat or a dog, being able to tell whether it is a cat or a dog. Like, this was the level of where computer vision was and where machine learning was at that time. And like, I think it must have been 2010 or something like that. Yeah. And so we're like, that's not that long ago, right? It is long in that, we're kind of
12 years. Yeah. And so 12 years is a long time in technology, but still 12 years is relatively short, given that my expectation for this stuff was to be much, much harder. So it would take decades.
Well, so the other thing is that I think it was like the field of AI is more than 12 years old, right? So it's back, goes back decades. Yeah. And so what's interesting is that basically if you extrapolate, 12 years is a long time, but look at the progress, right? So if a leading researcher was basically starting off with this kind of silly task of being able to distinguish cats and dogs, and then we blew through that. It didn't take 12 years to solve the cat versus dog problem. It took, I think, maybe 1 or 2 years, but definitely by 2014, like you said, like a lot of these ImageNet based models were able to do this type of task handily, right? And then we've moved on from object detection, we've moved on from question answering, we've progressively sort of knocked over all of these dominoes, and now we're getting to like not just doing these silly tasks, but talking about inference and reasoning and things like this. And so that's what's really astonishing, is that to the layperson, it's really hard to know like what is possible using computers and what is not. Right. And so, so like, just to give a sense.
Yeah, I think our audience would be able to tell us exactly which XKCD that is. Yeah. But yeah. It's always tough for lay people to tell like what is in the realm of possibility for engineers. And even Star Trek makes light of this, right? Like Kirk is always asking for things that are unreasonable, and engineers like, well, maybe they're just like, I just want it, right?
Yeah. So, but now, I think even for people like you and me who are in the industry, it's becoming increasingly hard to know what is actually plausible or not. Like, I think if you had your head in the sand, like let's say that instead of paying attention to AI, you were working on Web3 or something, you had no idea what's going on, right? And then
this guy,
and then somebody comes up to you and says, "Hey, did you know like now that there is a machine learning model that you can ask it like questions, give it silly pictures, and it's able to actually understand like what makes them interesting, or like it's able to describe the implications of what it's seeing." You might actually say, like, get out of here, right? Like, you're smoking something.
Yeah, so essentially, like, the thing that I ascribe to lay people, that inability to discern whether something is technically possible is slowly creeping into us, or me. Like if you don't work in AI, right? Like, so if you're in tech, like you also don't have that ability when it comes to AI technology.
Yeah, exactly. So yeah, these are all like super super interesting. So we kind of covered um, all of the different advancements from all these AI research labs. And so yeah, now I think it's sort of the fun part. What are the second and third order effects of having this type of power like within our reach?
I mean, it's well, so the immediate thing is that you can have agents that are able to do things on your behalf. And this has been the dream of people on the web since the 90s. For our older listeners, you might remember the push technology back in the 90s. And so the dream was that after the basic web pages, what you would be able to do is employ or deploy agents on the web to scour the web for information to do things for you, such as like book a vacation. So it would be able to go to disparate websites and do this. And the way that they would be able to do this is read semantic markup about what all the prices were, what the hotels were, where they were, and then use XML joins to kind of join things together to give you a list of possibilities. And so for
watch our other episode on semantic web.
Right, that's right. That's right. For our new listeners, you don't know, but like oftentimes we talk about this stuff and it's all connected somehow or another, and the threads of technology often intertwine, and unless you kind of put things together, you don't realize that these were all thrown together or tied together somehow. But yeah, like that was the vision. Like they were just like, we can't make computers that intelligent at the moment, so what we'll do is we'll try to make humans do more work by marking up everything. And so it seemed like they were part of the way there, but then never got it because, well, people are lazy. Nobody and people lie, right? And we talk about all these things of why people are like, humans are unreliable to semantically mark up stuff. So this sort of thing did not work until recently, I guess, with the deep learning, multimodal, and multitask agents or models. So I think that's kind of one of the near term things that would kind of come out of it. And I think I have worked when you and I met. One of the things I was working on was a CRM system that wanted to do something like this based on like your location, your calendar, context, and stuff like that. And I was like, oh, I recognize that this is something that is kind of beyond our reach. We might need to do something else, because like that task of like figuring out recommended next actions to take is really, really hard based on just those signals. And many people have tried since then, and I've seen it in the CRM space and also in the wearable space as well for this sort of thing.
Yeah, so I think that agents that are able to do things on your behalf are really cool. And what's even cooler is that we're seeing glimpses of reasoning in things like Flamingo. And if you've ever done anything like booking travel, like you're saying, it's not just being able to make some API calls to a flight service and pay money to acquire a ticket. Sure, I think like that is one component of it. But when you're doing something like book me a trip to Hawaii in May or June or whatever, it needs to be able to align a lot of different things, right? You need to also book some hotels, maybe also know what your vacation schedule is like so that it can book it during your vacation and not some other random time when you're working. Like so there's a lot of like different components that you have to put together in order to do this.
Yeah, and beyond that, it'd be great to know like what the local festivals were so that you can tell traffic and avoid it, that sort of thing. But like those aren't things that locals would know, right? But definitely like it'd be within reach of like AI agents. It seems like.
Yeah, definitely. So I think that's a really good example. Yeah, I think another one going off of the MIA model, the MIA model of the embodied agent, is actually having a kind of household robot. And when I say household robot now, I don't mean, again, bringing up Rosie from the Jetsons, like a, a fully functioning like thing that can do everything. But certainly, like if you think about something like a fancier Roomba, right? That rather than only doing sweeping of your floor is maybe able to, I don't know, like like
put
push some
stuff
things out of the
away.
way. Yeah, put stuff
No,
away,
like,
right?
yeah, put stuff away, because like one of the difficult tasks for AI for the longest time was just manipulating everyday objects. But
Mhm.
it seems like AI is well equipped to put that all together now, so that you can have a robot that like puts away the dishes in the dishwasher. I mean, even
Yeah.
that would be a great help, honestly. Like once I got the Roomba, it was great that it felt great. It felt like I was part of a two-man team. Granted,
Mhm.
like I was pulling most of the weight, but at least like it was somebody else like helping out with the cleaning, so that I didn't have to do that part, right?
Right.
And having somebody like some other machine that is just like putting cups away, or like putting the dishes away in the dishwasher, or just regular everyday things, keeping things tidy, like that can help a lot, especially if I guess, if you're messy, or if you have newborn children or something like that. Like for
Yeah.
parents out there, like that there's just no time to do much of anything. So either you drive yourself crazy or you let some stuff go. And so
Right.
having a equivalent of a Rosie, even a basic Rosie the robot, would help a lot with
Mhm.
just having keeping your environment sane. So
Yeah, exactly. And I think that yeah, it would be helpful for people who are busy, or they have kids, or things like that. Or even, I know that it was a sort of active area of investment from like Honda of Japan, like because
uh-huh.
they have a rapidly aging population, to have a kind of household assistant robots for the elderly. And I think that in Honda's robot, they had like a kind of humanoid robot that could like walk. It kind of walked funny and it looked like a human. You've probably
Yeah.
seen that.
Yeah. As an aside, do you get the sense that the Honda robots are all pre-programmed? Like
Yeah, they're all
it's
definitely
not
pre-programmed.
adaptive at all. So like one
Yeah,
misstep, like it would fall down the stairs head over heels, right? Like it's
yeah,
not. I've always wondered, like, why do they have an entire division devoted to making these things when it's clear that I have no idea. I'm just saying, like, there's just so much. Whether they like, it seems like it was a lot of wasted effort, especially in light of the current AI technology. Like, do you know if they moved
hmm
that in that direction at all, or maybe it's only for show? It's like a marketing thing. So
yeah. I think it was definitely a marketing thing, and also like I don't hear a lot of
papers written by Honda,
papers
right? So
papers by Honda, right? Like I think that they're not in the game, so
yeah,
probably not. But yeah,
yeah.
I mean, I think that it's a good problem, space to work on, to be able to help people with disabilities, or
Yeah,
aging,
yeah,
or
yeah.
other types of things.
Yeah,
And
yeah, yeah. It shouldn't just be moving stuff in the house that you're too lazy to do or you don't have time to do. But like
yeah,
definitely like people in Japan talk about this, because like robots have a different public perception in Japan than it does here in the US. Like robots are seen as friendly helpers
mhm,
culturally, as opposed to in the US as evil overlords that are dystopian.
right.
Yeah, and so I think there's a lot of different like philosophical things that you can talk about with this, but we're mostly concerned with like you said, like is this a good helper? And I think one of the big things that humans need help with is getting from point A to point B, and definitely we've are working on self-driving cars. But one of the things that I've wondered about was whether these like multimodal and multitasks models are used in self-driving cars, because I do know that when you're driving or in self-driving systems, you need to do a lot of image processing tasks or image recognition tasks. So you need to do like
Mhm.
object segmentation, or like object recognition, or any number of things. And so do you know if they use like multitask for that? Because it seems like it would make sense for something like that.
Yeah. So my understanding is that they do not use multitask or multimodal models. My understanding, and again, of course, like all of this is quite secretive, I'm sure, and proprietary. But
Right.
like my understanding from talking to people who work for these type of companies, as well as looking at just their org charts, the way that that they're set up, they have like a perception team which works on like the perception model, the vision, or like lidar 3D point model. Then they have another audio model, and then they basically take all of these different single purpose models, and they have another a layer called sensor fusion, which then fuses all of this information together, and then finally they have like a planning thing, which may be a trained model. It may use a special like handwritten rules to take in all these inputs and then actually make the car do stuff. So my understanding is that that's sort of all pieced together from these individual models built by individual teams, basically.
Fusion Sensory sounds like either a band name or an energy drink. but the but yeah, the way that they're doing it, if that's the case, it kind of sounds like feature engineering from machine learning a generation or two ago, where they did this sort of stuff by hand. And maybe you could argue that at this point you need to, because you need some sort of human in the loop. But I guess what I'm asking is whether they're doing like end-to-end training with self-driving. It sounds like no at the moment, and maybe that's for the best. We don't know. So
yeah, I mean, it's probably for the best, like in terms of how much like safety mechanisms that you need and how sort of understandable you need all of these components to be. Maybe, but like
maybe, or is it just to make humans feel better? Because like the whole thing that we're talking about here is that like these computers now with these models can do inferences, so it should be able to do safety inferences of whatever it needs to do. So that seems like it. And some of these other models, the examples and demos I've seen, you can ask it to explain itself. Now I don't know if it can lie, but like
oh man,
right, but you can have them be introspective now too, right? Explain like why they came to the conclusion that they did.
Yeah, I think that's actually a good point, which is that, by the way, when we're talking about an end-to-end model, I think what you're saying is that what if there was a single model, maybe like Gato or something, that then takes in all of the different input, the sound, the LiDAR,
right,
whatever,
the sensor data from the car, yeah,
and then is able to kind of like munge all of that together, and then its output is basically to take an action, like turn the steering wheel at a certain amount,
or step on the gas,
step
or
on the gas,
hit the brakes,
and all of that stuff. Yeah, so I think that one interesting point that you bring up is that these models now have basically their own type of human interface. They have a text-based conversational interface. At least that's the prevailing interface that people are building on top of these things. Right. So yeah, I think that it's interesting to think about to what extent these models are introspective. They actually know what's going on, and yeah, I think that it would be interesting also because, you know, when we're talking about these multitask architectures, learning from other tasks, like there's probably plenty of, you know, driving videos on the web that they could potentially learn from and generalize from.
Right. Like I'm laughing because I wouldn't put it beyond some human on this earth to post like their drive from, I don't know, like Los Angeles to Chicago or something like that, just because they're like, I got lots of GoPros, and so I might as well put this on my YouTube channel. So yeah, there's a lot of data for self-driving cars out there.
And not only like that type of data, but you know, when we're talking about the MUM model that could answer whether you could take your hiking boots to Mount Fuji, at least in principle, this type of model is able to learn from other types of data on the web, like, for example, knowing the nature of mountains and the kind of conditions that you'd have to endure to climb a mountain and things like that. You can imagine would be helpful for driving a car also, right? Knowing the effect of rain on a road without necessarily having seen rain on a road in a self-driving context. It still might be able to generalize, like to say, you know, rain makes things wet and slippery, and so therefore the car should be able to act in this way or that way. And so yeah, I think that inference aspect could be additive and could help in maybe cases where maybe the common path is very easy and they use the traditional methods, but how do you make the self-driving car react to a scenario that it's never seen before in its training data? Like you take it off-roading or something, or maybe it caught in an accident, right?
Or you drive off a cliff, and so it's like, I don't know what this is, but maybe I have a good idea.
yeah, exactly. It's like let's say that you just something unexpected happens on the road, and there isn't any training data from the traditional model or the traditional rules that they're using. Maybe it'll be able to use this type of multitask model to at least push it in the right direction, if not get it completely right.
Yeah, that would be hilarious if you drove it off a cliff and it inferred that you needed wings, so it would like fling the doors open or something like that in a
try to flap.
Right, a futile attempt to flap, I guess.
Yeah, I think that the question that would remain for this is what you brought up is, like, when you have this text interface to these models and you ask them to explain themselves, do they know what they're talking about? Like, are they actually able to understand what's going on within them? And then secondly, do they have the capability to lie, or if not lie, just make up random stuff because
Yeah.
they don't actually know, but they just have to tell you something. So they'll say,
Right.
why did you do this? And it would just make up some random thing.
Right. Yeah, because in the GPT-3 model, like if your goal is to have it generate something imaginative, then it doesn't matter. It can lie all it wants, right? And you're like, oh, it's being so creative, but that's like a form of lying, right? Because it's just making stuff up that seems it's internally consistent. But then if you're using it for something like, I don't know, cancer detection or driving, like you really don't, or like you're doing like criminal, not profiling, but like monitoring, I guess, like, and the system judged somebody to be committing a crime, like you want at least some way for it to explain itself, because that stuff needs an audit trail so that humans in the loop can understand why it made the judgment that it did, right? But if it can lie or just make stuff up because it feels like it has to give an answer, so it just makes something that's internally consistent, then, but not like consistent with what's happening in the real world, or like our notions of morality, or like whatever it considers external to its system, then it's just not going to work. And so I don't know that we can have that.
Yeah, so I think we're a bit of the way there, and probably wouldn't want to plug it into my car just yet. But it's a good area of research, right? Like both the explainability aspect as well as seeing what multimodal models could do. Could they, at least in a closed environment, to be able to drive a car? Yeah, that'd be a cool experiment.
Yeah.
Yeah. So the other part that I wanted to talk about is that if we're talking about multitask architectures, and just as a reminder, like a multitask architectures are those in which they can generalize across multiple tasks, some of which maybe they haven't seen yet, but use the knowledge that they have from the training data from one task to be able to solve a new and novel task. So in this multitask architectures, could you have sort of a multitask model as a service? So basically, when I say this, I mean you can think about it as like a central brain, like a central model that is sort of shared, maybe it's hosted in the cloud or something, and then everybody uploads their training data to it or somehow trains it for their particular task. And then by nature of this model being multitask, it gets better and better. It gets smarter and smarter. And so then you actually benefit from the scaling factor. It almost becomes a network effect where as this thing sees more types of tasks that people give it, it gets better and better, and then it creates more incentive for people to then use that rather than making their own machine learning model and gathering all the training data and doing all that stuff for it.
Yeah, like when we were talking about this in our pregame, like I was imagining it as akin to something like open source, where open source usually refers to like a code that is freely inspectable and in some cases like freely usable. In a lot of cases it's freely usable. And so I was picturing the same thing with like weights, because right now a lot of the weights and models, you have to dig kind of hard to find them. Like they are available as repositories, but I wish it was more live and active in the sense that the model is always kind of on as a service. And here as a multitask, like you would tack on the final couple of layers for your task specific thing, and you would train that to your liking and satisfaction. But because it's a multitask where everybody shares all the lower levels, then by virtue of you improving your task and getting your task done, you improve the shared model that everybody uses. And so in that way you have like I guess if it's a general thing, you would only need one, right? Like you don't need ones that like specialize for, like you don't need ones that are specialized in some domain. Like it would be general. Right. So you only need one, right? So then that means like people talk about the web as the nervous system for the planet, but like this would literally be like an actual brain for this specific planet.
Yeah. Like you can when you mention like a multitask as a service, I'm imagining like a brain in a jar that like is plugged in with like some Ethernet cables, and it like is answering questions for everybody.
Right, and like the more tasks and more questions it answers, the more that it understands and trains on the tasks that we give it, regardless of how related they are, and it's able to build up its embedding space, or I guess in layman terms we would call it like a mental model or like conceptual model of how the world works. And so that should be a possibility. The scary thing to me is like whether somebody would want to own that, because it could prove to be very lucrative, but I guess it would push it would be one of those things I think that would push humanity forward if it was globally accessible to everyone, so that you could have assistants to help you do either creative work or research work. Because like normally you think that like with idle hands people would just do nothing but play video games and eat food, or I don't know, whatever it is, but there's plenty of people that are amateur X, Y, and Z, like gardeners or whatever. Like people's like elevated hobbies are small niches, and those things could use a lot of creativity and help. Like even like choreography, I imagine like computers, like these learning models would be able to help with like innovative choreography that like if you could do it in Go, where people like describe that as, what is it, move 74 was so beautiful.
Yeah,
I think it was 74, right, in the Deepmind. Then I don't, it doesn't seem with beyond the realm of possibility that you have the AI as an assistant to help generate possibilities for choreography that normal human beings wouldn't have thought to do. So that would be pretty interesting. So that would be globally accessible and help push like human culture forward.
Yeah, I think you're being an idealist.
We gotta start somewhere, right?
No. What I'm saying is like I think you're coming at it from the open source, like freely available aspect of things. And
I think
I
it's
am like more thinking it would be a service that like would become this like centralized network effect type situation.
Is it private that you're imagining?
Yeah, like I was imagining that like Google would have Google Cloud Brain as a service, and then everybody makes it better and better, and then like it becomes like a what do you call it, like a monopoly type thing.
Yeah. I mean, that's one of many possible futures. I think like there are like in the cryptocurrency world, like people don't want to hear it, but there's a lot of underlying work on decentralized technologies that so you could. It is possible to host these weights and biases for these models on a decentralized network so that no one person owns it. And I think it's not outside the realm of possibility to have it running also, but right now a lot of the decentralized technologies are focused on storage, and so less on decentralized computing. Well, that's not true. Like Ethereum is decentralized computing, but like because everybody has to run the same code, like it's really slow. And so they're trying to find ways to scale it so that somebody can run a piece of code and you don't have to run it yourself, but be able to verify that they did the right thing. And so we talk about this in our previous episode on zero knowledge proofs. So you guys should go check that out if you can. And so so I think that that's a likely possible future if like it's a central repository in like Google Brain that people use. I was coming at it more from an open source sort of thing, in that taking analogy from history of the web, not in that because it was freely available, it changed a lot of things about human culture, technology, progression, any number of things, because it was democratically available. And so I imagine that if this was at least freely accessible to regular everyday humans, that you will see both innovative, beautiful things that push culture forward, and you'll see a lot of nasty, innate things as well as dangerous things out there. So you'll get the equivalent of cat pictures, and you'll get the equivalent of like snakes on a plane. So I mean, like those are both things that the internet made possible. So
I like your where you're going with maybe combining these multitask models with decentralized computing, like where maybe this is a shared resource and it's updated in a decentralized way, and then you could create some incentive structure for people to host it and run it and maintain the upkeep of this type of thing.
Right. So it becomes a literal public utility rather than something like owned by a corporation.
Yeah. So, I mean, that would be super cool. I think that would, like you're saying, like unlock a lot of creativity if everybody had access to an AI. And I think like one thing that always bothered me when journalists and things would write about machine learning and stuff would be they would say things like an AI has learned to like do this thing or that thing.
They anthropomorphize it, or
anthropomorphize it. Yeah, that's the right term. And I think up until recently, that was not the right way of thinking about it at all, because it's not an AI has learned to like whatever play a game. It's that a team of researchers has run computer code to create a model that can do this game, right? Like up until recently, it was like that. But I think now, as we're thinking about multitask models and that can generalize to new types of tasks. You can sort of ask them what they're doing and ask them to reason about things. It is much more like an AI has learned how to do this. Yeah.
It's more akin to what the journalists. It's the same thing I was talking about before with the movie Enhanced Pixel. Like we used to laugh at that, right? But it turns out that like technology caught up. They were visionaries. They weren't like we were laughing because it was like we thought it was wrong because it was a misunderstanding of what technology could do, but it turned out that like they were just visionaries in the future of what technology could be. And so that's in the end we got to eat our own foot. And so maybe the journalists had it right. They were just a little too early with how they described some of this AI. So then some of the other things that I wanted to get to are more, I guess, further on, like as a result of our conversation so far, the things that we talked about are in the near possible future. But like, I think that the times where we have a lot of fun is when we talk about the far possible future. And so I think with a lot of things, we have a good understanding of the technology. So we're able to project out that far with our technology optimism. But here, I think it's a little dangerous because like we can imagine generalized AI to do almost anything. So maybe it can become a little unhinged, but I'm relying on you to kind of tether us a little bit here. And so I think one of the things that I thought was interesting was like, is it possible now for AI to learn a task of where you don't have direct data on that task? So like maybe you need the task to fly, but you like for a robot to fly or something like that, or to do archaeological research, but you don't have any of that data. But instead you have a lot of data on driving, you have a lot of data on like walking or something like that. You have like books that talk about like bird physiology or something like that. And so could you train on that data and then be able to have it like fly in a robot? Like, is that possible?
Yeah, I think that the jury's still out on exactly how these multitask models are benefiting from learning these different types of tasks, and like in exactly what way, quantifiable way, one task is enhancing or even perhaps detracting from the performance of another one.
Right.
But yeah, I think that is not like absurd, right? If you think about it, like imagine the way that you learned to drive initially. Cars were invented very recently in human evolution. Our brains actually don't have a car module, right? But somehow, just based on our idea of like how motion works and like walking and whatever, doing some other stuff in the world, like within a few episodes of driving, like you're able to reasonably drive. So like, yeah, it seems.
But that's usually what we like in layman's terms call intuition, right? We can use our like skills, knowledge, and experience and kind of do some sort of simulation in our heads to infer like what something is going to be like. But then like there are other things that we admit to being out of the realm of human ability to describe or talk about. And so I wonder if there's also a similar limit. And so I think recently I was talking about I was reading an article that talked about a book that was written about like what are animal experiences like, because their senses are, a lot of them are so different than ours. And so the thought experiment is like, if there was a human, a bat, a bumblebee, and whatever, like in a room, and all of a sudden it goes dark, like what would be the difference for everybody? And so like for a bat, it just wouldn't matter because it uses echolocation, right? And then there's other ones where like I think eels use electrostatic or something like that, and then spiders use vibrations to sense their world. And so like lights going out would make absolutely no difference to them. And so and then a lot of mammals use the sense of smell, and so their world is like full of smell. And so like the senses that you have available to you are very much influences your perception and experience of the world. And so for us, when we don't have that, it's almost beyond comprehension. So if you want like for me to train to be a mole, like it'd be really hard because like even all of my like previous knowledge and experience can't really tell me like how to do the things that moles do to say hunt for an insect, right? Like it doesn't generalize to that. But and then similarly, a mole, if you take a mole and try to generalize its data set of experiences and whatever to doing linear algebra, like or driving a car, it just it doesn't generalize very well. And so I wonder if there are similar limits here.
Yeah, no, I think that's like a good point, and it's I think a lot more research has to be done about what exactly is happening when we say generalizing across tasks or generalizing across modalities. The other thing that I would think is that I like the direction you're saying about like let's not just apply our human centric idea of how thought or like the brain works,
Uh-huh.
like because other animals have other senses and stuff like that. And
Right.
actually, if I were to guess, like if we were to think about this type of models as a different type of animal, and like what type of sense does it have that we wouldn't be able to understand or explain that it could use to its advantage? One thing I'm thinking of is that these models have a sense. Imagine if you had a sense um, that of the web.
Yeah, I
No,
see.
like that there is something, this type of knowledge, like a vague sense of knowledge based on like you're plugged into this web.
I think what you're saying is like, what if you had like we have spatial reasoning with the world around us, and it's almost to
Yeah.
the point of a background process or intuition. What if you had something similar for the web, in
Yeah.
which like you would have monitors around the web, and you could get a sense of the either the shape of the web or like
Hmm.
what people are talking about, and so it would,
Yeah.
I guess it would almost be like the Borg, where like you have a sense of the hive mind, right? And so we have a
Yeah.
glimpse of that with something like Twitter, even though it's segmented, so you kind of know what people are talking about in real time or something like that. But
Right.
you want it to be an experience.
Yeah, exactly. And like in some sense, a lot of these language models they've already been trained on, a lot of the web pages, like much more web
Yeah.
pages than a human would ever do. So that some of that is baked in, and then potentially you could have them continuously ingest like new content as it's produced, maybe from Twitter or maybe from news and things
Hmm.
like that. And that could also be a type of sense that's feeding into it, because if you ask a human about some question, like they would be able to apply the human intuition, but then this type of model, it could have an advantage in that it's very, very well read and sort of aware of all information as it's being produced.
Oh man. Then relatedly, like supposedly people that use GPS apps to navigate driving have a smaller hippocampus than say taxi drivers that have
Mm.
to map that sort of stuff in their heads. Well, it used to. Like all Uber drivers use mapping things now, but and so
Yeah.
hippocampus is like this little organ inside your brain, I guess like suborgan that does a lot of
Mm.
the spatial reasoning and long-term memory, I believe. And so if we are able to get a sense of the web and it's able to do the inference for us, then would that ability in humans just atrophy over time?
Yeah, I mean, I think that's what a lot of the AGI safety and ethics type people are thinking about, is all these different social implications, and I think that, yeah, I mean, the one thing that stands out to me that there's still space for, or like where you could have this like human model symbiosis, is that the important part of things, the important part of like let's say software engineering is actually not the writing of the code, although like that is important in order to get the job done. The important part, as you especially get more senior, is that you identify problems. You say, okay, this thing is important for the company, or it's important for our group to accomplish, and then being able to frame that problem and then execute it, right? And so like maybe the execution part is getting done by the model, and then humans are like framing the problems.
Right, but if these models can do inference, what's to say that I wouldn't use it to do the problem statement and stuff like that?
Yeah, I think that's probably where the science fiction, like I think that is still in the science fiction, like the level of
For now,
inference
at
that
least, yeah.
like yeah, like that these models are doing is still very much like a rudimentary type of inference, and like not necessarily like having a intuition for like this thing will be important to our customers, let's say.
Yeah,
Um,
customer dev is apparently the ultimate frontier for AGI. Yeah,
yeah,
yeah. I mean that's something I can buy, because I think on both sides of the argument, where some people are too quick to say computers will be able to do everything, and people on the other side where nah, they're too far. Both are probably wrong.
yeah.
I think the reality is probably somewhere in between. Yeah, I can buy that.
While we were talking just now, I was just browsing through Twitter, and there is a sort of breaking development in this
Oh,
topic that we're
really?
talking about.
We're on news. we're a news.
Yeah,
show
we're
now.
breaking news
Right,
with the
breaking
little
news.
screen.
Right.
So there is another model. It's not multimodal, but it is a multitask model, a conversational model out of Google called Lambda. It's been publicized at Google I/O and things like that. That, but somebody who I think has gotten fired from Google now leaked a transcript of talking to this model and has titled this transcript, "Is Lambda Sentient? An Interview." This was published yesterday, as of recording this podcast, on June 11th, 2022. And basically making the case that maybe this model is sentient. And this is going to be quite a show. I'm sure a lot of people are going to have a lot of thoughts on this. We will link it in the show description. So far I have not gotten to immerse myself in this latest development. So, but yeah.
There's just too much to keep up with.
Yeah.
But yeah, I think we covered a lot of things.
Yeah, so we have talked through a bunch of these implications, and there's I'm sure a ton more, and there are new models coming out every day and new controversies coming out every day about the existing models. But I think that to kind of bring it back to the framework that we like to think about. So these are all the implications, and how can we get there? I think that we're pretty close to a lot of the things that we talked about, a few steps on, a few more publications and a few more architecture revisions to getting to, maybe some household helper robots and things like this.
Are we that optimistic? Because previous optimism in AI before resulted in large AI winters. So how sure of you are of this?
I think that we're pretty close. I think that the fact, like I said at the top of the episode, the fact that these research labs are putting out press releases about these models that would otherwise sound completely absurd, but they're doing it with a straight face. I don't think that it would be rational of them to do this unless they felt like things were moving in that direction. Of course, there's going to be a bunch of work in order to get these out and working in the real world. I think that the last 20% or last 10% of work is going to take up maybe the next decade, but I think that at least an 80% good household robot would be feasible in the next couple of years, and then the rest of the time would be actually making it handle all of the different little edge cases.
Right. Not insult various groups and not be a dick to everybody that uses it.
Yeah, exactly. But the main thrust of it, the main idea of it is probably, feasible.
Yeah. I see. Yeah. So like you said, we cover a lot of ground, and this is one of those things that I think will change. Out of all the things that we talk about, this is probably going to be one of the biggest changes that's coming. I don't know. I think we talk about a lot of game-changing technologies. But yeah. Overall, this is the most obvious one with I think the most unclear future out of all the ones that we talk about. But yeah.
Yeah. Totally.
So yeah, I mean, I guess we'll just keep waiting for the researchers to do stuff, and then eventually the application developers and founders will pick it up, and sooner rather than later we'll see these things infiltrate our lives, for better or for worse. So yeah, we definitely, for our listeners, we have definitely plenty of other episodes with mind-blowing insights into the latest technology across different parts of technology, and we try to cover the gamut. And so tune into other stuff. Shalaka, subscribe, share. I always forget what share, subscribe. Yeah.
Subscribe.
Hit that bell, whatever it is that you need to do. We have more interesting tidbits about the edge of technology coming up. So Shri, do you have anything to add in our closing bits?
No, I think you covered it. Also, just put us some comments in the comment section for what you think, how close we are, and potential other use cases. Imagine that you had these models as behind an API. What would you build? Would love to hear it.
That's right. Yep. Let us know down in the comments in the obligatory pointing. So anyways, Shri, point.
Oh, there you go. Okay,
yeah,
cool.
there we go. All right. Anyways, so this is Will.
And this is Shri.
Signing off, and we'll see you next time on another episode of the Technium. Talk to you later.
Bye.
Bye-bye.